saying our focus is about linear programming. And with linear programming, we are saying that sort of any calculation or any problem, you will actually be using either method that we use. We are going to be using either graphical method and or simplex method. Those are two methods that we actually use. When do you use graphical method? You use graphical method only and only if you're dealing with two variables. That is, for example, you have x and y as your variable. You cannot use graphical method when you have more than two variables. Because with graphical method, we know that you must be having a vertical axis and horizontal axis. There is no way you are going to present another variable on your graph paper. You either have vertical axis and horizontal axis. There is no way. If you have, let's say, another variable called z, that one you cannot use graphical method. So when are you supposed to use simplex method? Simplex method can be applied anywhere, whether you are dealing with two variables or more. So it means that where you're given a question and they have not specified the method to use, it's you to determine, am I going to use the graphical method or I'm going to use simplex method? If you're dealing with more than two variables, automatically you must use simplex method. That is automatically. If you have, let's say, three variables, you must use simplex method. However, even if you have two variables, this simplex method can also be applied. So that is the first step you need to know, that as we handle our calculations, we are actually focusing on two methods, graphical and simplex. Graphical, only two variables. Simplex can be two variables or more. Then with linear programming colleagues, you need to differentiate between decision variables and the constraints. You need to differentiate between your decision variables and the constraints. Decision variables, basically we are talking about options available, or what is the focus? What is the focus for the company? Are they going to produce products? And if they are going to produce products, what are those products? So it means that once you know those products, you can easily tell, you can easily confirm that those are your decision variables. So it depends on the question you're handling. Then with constraints, basically these are limiting factors. If you were to produce a certain product or different products, what are some of the items, what are some of the factors that may hinder you not to achieve your objective? Okay, so those are constraints. Let's say your aim is to maximize profits by producing more products. But we all know that we have some of those factors that may limit you not to achieve your objective, not to produce the more you may also need according to your wish. We have those factors that may actually limit you. Talk about storage capacity. As one of your constraints. Talk about labor workers, labor hours. You may find that you're limited with the number of hours available. Talk about the machine hours. You have machines, but you cannot use your machines for more than a specific time. It can limit you. Talk about your materials. You may need to produce 100 products, but do you have enough materials to do so? So all those can be your constraints. All those can be your constraints. And what you need to know is that within programming, each constraint forms an equation. Each constraint forms an equation. Each constraint forms an equation. That one should be in your mind, that when I'm dealing with constraints, when I confirm that this is my constraint, that constraint I have must help me to formulate an inequality. So if you have 4 constraints, those will be 4 inequalities. And 4 inequalities are going to help you to come up with 4 equations at the end of it all. So once you differentiate between decision variables and constraints, you will be good to go. Then another aspect is about the steps that we follow. Steps followed while formulating a linear programming model. Step number 1, we have to identify and define our decision variables. You identify and define decision variables. For example, you at this point you want to know what is the focus for this company. Is it to produce some products, and what are those products? You are trying to identify those products that this company wants to produce. Okay, then once you identify those products, you have to define, because you cannot keep on saying, okay, this is Mukwano, they want to produce, let's say, soap and all that. You cannot keep on using soap. No, you have to define your decision variable by just saying, let's say X represent the number of soaps or anything that you are dealing with in the question. Y represent something you're dealing with in the question. That is defining your decision variable. Then once you identify and define decision variable, number 2, you have to state the objective. What is the objective of this company? The objective is always either to minimize costs, or to maximize profits. That is always our objective when we are dealing with linear programming question. Once you identify and define your decision variable, the next step is to state your objective. And in the question, you're only dealing with one objective. You cannot find that you're handling two objectives. It is either to minimize costs or to maximize profits. Full stop. You cannot handle two objectives in one question, no. So if it is to minimize costs, how are you going to state your objective? If at all you had, let's say X, you had X here and Y as your decision variables, when you're stating the objective, if it is to minimize, you can say P max, P min. P min will be how much you want. We shall see how we can formulate this, but this is just illustration, how you can actually come up. This means that if you want to minimize costs, you want on product X, on every product of X you want to produce, you wish to minimize a cost of just 10. On every product of Y you want to produce, you want to minimize a cost by 9. This is the meaning of this. If it is to maximize profit, we normally use Z, but you can use any letter. You can use Z, you can use K, as long as you show that this is K max, to show that you are actually dealing with maximization. So if you are to maximize profit, it is also the same. It can be 10x plus 9y, meaning that on every product of X, you want to earn a profit of 10, and on every product of Y, you want to earn 9. That is the meaning. But the reason why you're adding is because you want to know the overall profit. What can be the overall profit from these products? What can be the overall costs here that you have minimized? Okay, so we are going to be observing our questions. In the question, they will always give you this. They will always give you some figures that can help you to come up with your objective. The same way I'm doing here. They will clearly be telling you maybe they want to earn a profit of this on this product and profit of this on this product. Sometimes they don't use profit, they can use contribution, they can use yield. So here when you see those words, when you realize that there is no profit in the question, ask yourself, are you given something related to yield? Are you given something related to return? Are you given something related to contribution? That's how you can easily track this. Once you state your objective, number 3 is state the constraints. State the constraints. Now, you state your objective, the next is state the constraints. Constraints, as I said, these are factors that may limit you not to achieve your objective. And I said these are some of the constraints that you may be dealing with in the question, and others depending on how they have phrased the question. But as I said here, when you're stating your objective, each constraint is going to help you to formulate formulate equation. So this can be your constraints. As we are going to see moving forward, you have to state those constraints so that they can help you to form your equations. Then lastly, once you state your constraints, of course, these constraints will be limited to some figures. If it is storage capacity, they will be telling you that you have only the capacity that is available is, let's say, less or equal to 100. You cannot exceed 100. They can tell you that. Maybe labor hours, they tell you the hours available are only let's say, if they say the hours available are only 100, you should be knowing the inequality to use. If they say for you to produce these products, you need a maximum of 100 kgs as materials, you need to know which inequality to use. So a quick one is that you need to know these things. If they say maximum of, if they say minimum of, if they say more than, less than, because those are the words you're going to be looking for in the question. Available, then up to, does not exceed, those are some of the words you may be interested in the question. If they say maximum of, who can suggest which inequality can you use here? Maximum of, if they say maximum of, let's say 100 kgs, which inequality can you use? Who wants to try?
You can use the greater or equal to.
You need a maximum of 100 kgs. So you have to use greater
Or
or
equal
equal
to.
to. Then if they say a minimum of 100, which inequality?
Less or equal to.
Then more than, less
Greater.
than, this is automatic. What about if they say the only space that is available is 100 seats? What can you put?
Less or equal to.
Less or equal to. It means that you cannot exceed that value. Then if they say you have up to 100 kgs, or you have up to 100 hours to produce all your products, this is also less or equal to. What else? Does not exceed. It is also less or equal to. Among others, depending on how the question will be phrased. But these are words that are going to be helping you actually to come up with inequalities. Every time you see the word maximum of, every time you see the word minimum of, every time you see the word up to, they are calling you that at that point, you should put inequality. And the moment you're putting inequality, that is your constraint. That is your constraint. Without that inequality, that one cannot be a constraint. Because that inequality is just a limiting factor. Altogether. With this objective, when we are stating our objective, we don't put inequality anywhere. We only put inequality when we are dealing with constraints. So, step number, any question before we proceed? Here, any question? So far, so good, or there is a question? Please feel free to ask. So step four, once you state your constraints, step 4 will be to state non-negativity. Non-negativity. When we are dealing with linear programming, we don't expect negative values. So you're restricting yourself by coming up with what we call non-negativity function to restrict all your values to be above negative values. It can be 0 or above. We don't expect negative values anywhere when you're handling linear programming number. In short, you cannot produce negative quantities. That is always our assumption. You either produce or don't produce. So non-negativity, if your variables are only 2, non-negativities will be x should be greater or equal to 0. Then y, also y should be greater or equal to 0. If you have z, also z should be greater or equal to 0. You are limiting your variables not to have negative values. That is all about non-negativity function. So whether you are using graphical or simplex, you need to always know that these are the steps we follow to handle the number. You have to first formulate linear programming model before using any method. And they can ask you this theoretically. You state or you describe the steps you follow while formulating linear programming model. And you find that the question is taking 8 marks. So those are the only steps that we have. So from here, we can start handling our numbers. So question 1, on the required part, they are telling us that we formulate the above problem as a linear programming problem. That is linear programming model. So to formulate this model, we have to follow our steps. Those 4 steps, you have to follow them. Then you have commenced to determine how many items of each type the workshop must produce. Here, something should come into your mind. Something should come into your mind that actually here, workshop is producing something. And it will help you in terms of defining your what? Your decision variables. You need to know how many items this workshop is interested in to produce. Then at the end of it all, they are telling us that we determine the maximum profit the workshop would reap. So we analyze our case study. As you analyze your case study, what are you interested in? You're following your steps. You're following your steps to form linear programming model. Identify and define decision variable. So here we are trying to see what are our decision variables in this question. They are telling us that Kasokoso Art Craft Workshop has 3 machine types. They have 3 machine types for crafting, finishing, and spraying. They have 3 machine types for crafting, finishing, and spraying installed at their workshop. Machine types 1 and 2 are capable of being operated at most 12 hours. What comes into your mind, colleagues? At this point, what comes into your mind by reading this statement? Machine types 1 and 2 are capable of being operated at most 12 hours. What comes into your mind?
It's 12 hours and below.
So it means that actually here you have inequality at most 12 hours. But this inequality is corresponding to what? It is corresponding to machine type 1 and machine type what? Machine type 2. Then machine type 3, they are telling you that it must be operated for at least what? 5 hours a day. So that is another constraint, at least. These are the words you must be looking for in the question. To know that actually, oh, this is not my decision variable, because they have indicated this word. The moment you see the word at least, at most, it means that machine 1, machine 2, machine 3, those machines cannot be your decision variables. Those are constraints. Those are constraints. For you to use these machines, they are restricted to time. Okay? Okay. So you have observed actually your constraints are related to machine 1, machine 2, and machine 3. Okay, we continue. Currently, the workshop produces only 2 types of artwork. Currently, the workshop produces only types of artwork. That is M and N. Currently, the workshop produces only 2 types of artwork, M and N. Here they have helped you to define. Are you seeing that, colleagues? And they are telling you that each requires using all 3 types of machines. So these are your decision variables, M and N. The number of hours required to produce 1 unit. The number of hours required to produce 1 unit of each artwork, type M and N. 3 machines are indicated in the table below. So here we have machine 1, machine 2, machine 3, and these are a number of hours required on each machine. For you to produce M, you need 1 hour of machine M. You need 2 hours of machine 2. You need 1 hour of machine 3. Like that. They are telling us that the workshop makes a profit. Do you recall what I said? It is either to minimize profit or to minimize what? Costs. So here they are telling you that the workshop makes a profit of shilling 600,000 and shilling 400,000 on each of the items M and N produced respectively. So this statement is going to help you to formulate your objective function. And the fact that you're dealing with profit, it means that actually your aim, your objective should be to maximize profit. That's why you even have this Roman 3, determine the maximum profit. So we can start, we can formulate very fast our, now get your book, we formulate our linear programming model. Question 1. We are formulating linear. Here are our decision variables for this question. Are what?
M and N.
M and what?
N.
That is number 1. Then what is our objective function?
Maximize.
Here our objective function, we are to maximize profit. Z max is equal to how much is profit on M? Profit on M is how much?
600.
600 M and N respectively. Then this 600 is corresponding to M, then 400 is corresponding to N. So this is 600 times M, because I don't know how many items related to M. Just that I know on every M I produce, there is a profit of 600,000. So I add, for N is how much?
400.
400 N. And your amounts are in shillings. Or you can reduce by saying, sometimes you may find that people are deciding to keep 3 zeros. So this is our profit function. This is our profit function. Then next, we need the constraints. In this question, how many constraints do we have?
We have 2.
We have how many?
2.
Only 2.
Right.
How many constraints do we have in this question? You have machine 1 hours. Remember where we said at least, at most, at least.
Yes.
At most, this is related to machine 1 and 2. Then at most is related to machine 1 and machine 2. Then at least is related to machine 3. Agnes, kindly mute. So we have three constraints. Machine 1, then machine 2, and machine 3. But when you observe clearly, these machine types are rated for, the first one is for crafting, the second one is for finishing, the third one is for what? For spraying. So that one should also be in your mind. Now they are telling us that these constraints affect all our decision variables, and our decision variables are only m and n. M is required to use how many hours? Basing on our question, this is M for machine 1. It's supposed to use 1, and for machine 2, M is supposed to, you need to use 2 hours at produce item M. Then you need to use 1 hour for produce. So we can indicate this. Kindly, if we are dealing with M, you let me know. I write 1, 2, and 1. This is M. For machine 1, we are using how many hours? 1. Machine 2 related to M, we are using how many hours?
2.
2. Then machine 3, how many hours?
1.
Only 1. Then for N?
2.
2. Next.
1.
Then next.
1.25.
1.25. Perfect. These are limited to our constraints. For machine 1, they said they used which word? At most or at least? They said machine types 1 and 2 are capable of being operated at most 12 what? 12 hours. So which inequality are you going to put?
Less or equal to.
If you add this one plus this one, it should be less or equal to?
Control.
So this is less or equal to 12. Then same applies here. Less or equal to 12. Then machine 3, they used what?
At least.
At least, which symbol should we use? Must use greater. Greater or equal to what?
Control.
Are you sure? Machine 3 must be operated for at least 5 hours. So here we put 5. So in short, what we have is that now we can combine. We can get M times 1 times M. What do you get? We get M, then we add. What is 2 times N? You get 2N. These ones should be, if we sum up, should be less or equal to 12. That is inequality number 1. Then inequality number 2, 2 times m, which is 2m. Here it is 2m. Then we add what? 1 times n, you get n.
N
And this should be
less or equal to 12.
less or equals 12. Then here it is 1 times m, which is m
M
plus 1.n
1.25 N
should be what?
greater
Should be
or
greater or equal to.
equal to 5.
So this is your these are your constraints. The last step is to formulate what? Non-negativity. And our non-negativity, how many variables are we dealing with? Recall what I said. You should recall what I said. With non-negativity, we have our decision variables as only m and n. These should be limited. M should be greater or equal to 0. Then n should also be greater or equal to what? 0. And you're done with your linear programming model. Any question? We are done with Roman 1. So we are done with Roman 1, we go to Roman 2. With Roman 2, they are telling us we do what? We use graphical method to determine how many items of each type the workshop must produce. But before we go to Roman 2, I want to look at the next question so that we can also formulate linear programming for the next question, linear programming model for the next question. Because that is the only challenge with this linear programming number. You must know how to form. You cannot fail. You cannot fail here. For question 2, we are going to come back to this. For question 2, we are to use graphical method to determine how many regular and derelict clocks should be produced on a daily basis so as to maximize profit. So the objective is also to maximize profit. But you cannot determine that minus linear programming model. So we can formulate linear programming model for this question together. We read through our case study. We identify decision variables and define. Then number 2, we state our objective function. Then number 3, we state our constraints. Number 4, non-negativity, full stop. So this question 2, they are telling us that Gonda Clock Company produces clocks of 2 types. regular and derivatives. What comes into your mind? At this point, what comes into your mind?
We have two variables.
These are decision what? These are decision variables. Just that at the end of it all, we want to know how many are those corresponding to regular and how many are corresponding to derivatives. So we can now define for question 2. For question 2, linear programming model. We said number 1, our decision variables are regular blocks and derivatives blocks. But you cannot keep on using regular and derivatives. You need to now define. You say let, which letter do you like? Let x be number of regular. Let x be a number of regular clocks, and also let and y can be number of you have identified and defined your decision variables. Number 2, do you have objective? You can write objective function. Objective function. We know that it is to maximize, but at this point we don't know. So if you don't know, you can skip this line, but you state that you can come back later. You leave like 2 lines, then you go to step number 3, which is constraints. So they are telling us that the electrical components necessary are supplied. The electrical components. Please, as you read, try to analyze, because this is a subject that requires you to apply critical thinking. So try to analyze and interpret. They are telling you that the electrical components necessary are supplied by another company whose supply is limited to 600 components per day. What comes into your mind? The electrical components necessary are supplied by another company whose supply is limited to 600 components per day. What comes into your mind? Okay, they are telling you, if you proceed, they are telling you that each regular clock requires 5 components and each Dirk's clock requires 6 components. Before you proceed, you must interpret this statement correctly. What comes into your mind? Are you seeing something like a constraint? Which inequality do we have from here to here? Which inequality have you observed?
Less or equal to
Where?
600.
They are telling us that the electrical components necessary are supplied by another company, whose supply is limited to 600 components. These 600 components are not restricted to each type of produce. It's just the overall figure. At this point, you are not reading anywhere like regular clock or Derrick's clock. You are not reading that anywhere. So it means that this 600 is overall. It's overall. And the fact that they have told you that it is limited to 600, those are the only components you can receive from your supplier. But they are telling you that each regular clock will require, for you to produce regular clock, you will need 5 components. And for you to produce Derrick's clock, you will need 6 components. So we have observed that we actually have our constraint, which is a component supply, or just component. You can remember each constraint affects your decision variable. How many decision variables do we have? We have X and Y. For me, I like by starting with what? With a constraint limited to, it is less or equal to how many hours? How many components? It is limited to how many components?
600.
Wanji?
600.
600.
600.
And for X, it requires how many components? Each clock requires how many components?
5.
They are telling us it requires 5. Then for X, it requires 6. So I come here and put 5. Then here I put 6. In an exam, that's how you should be actually interpreting these questions. Then next, the production of one regular clock requires one man day of labor. Are you seeing the language? 1 man day of labor. Recall we said also labor can be part of your constraint. Then they are telling you that Derrick's requires 2 man days. And the continuation, they are telling you that the production labor force has on a daily basis 160 man days. What comes into your mind? Which constraint are you seeing here that is related to labor? Which constraint are you seeing? The only days available. And available, we use less or equal to. And we have 160 man days. But each or one regular clock requires how many days? The production of one regular clock requires one man day. So here you put 1. Then for y, someone tell me.
For y is 2.
For y it is 2. Then next, we are done with labor supply. We continue. Next here, they are telling us that the production takes place in 2 different departments. The production takes place in 2 different departments for each type of crop. Okay? Here there is nothing, just they are giving you hint. There is no way, when you're interpreting, your mind should be in terms of identifying the constraint, the limit, the inequality available. But here there is no way you can, there is nothing like inequality in this statement. The daily departmental capacity. Remember, capacity is one of the constraints. The daily departmental capacity for regular is 80. And for Dirks is 60. They are telling you that a profit of this one will help you to formulate objective function. Now, from this statement, how are you going to formulate your inequality? Because when you observe here, it's actually they are showing you that the daily departmental capacity for regular is 80 and for Dirks is 60. But they have not shown you the overall. They have not shown you the overall departmental capacities for the company. They have not shown you that. In the situation where they have not shown you the overall value, you have to create, you have to look at each separately and formulate inequality for each separately, because you cannot combine. You combine together where you have the overall total. Here you don't have the overall total capacity. If you combine, you will not get that limiting, that inequality, like the way we are doing here. Like the way we are doing here. If you combine this and this, you see that the available components are what? Are 600. Labor, we combine because we combine X and Y because actually it's this that is available. So what will happen is now you will formulate each separately. Departmental capacity. Just what you do is to show here is just is your life. If you want to ease your life, you look at each separately. Here I'm putting 0. I want to look at each separately. And once you get used, sometimes you will not need this. You will just need to immediately be doing this, because this is what is necessary. Just here is trying to interpret the question. Departmental capacity for X is what? In our question.
80.
80. Then departmental capacity for Y. If I'm dealing with Y, I put here 0, Y, I put 1. It is still also this. Then for Y is
60.
perfect. Then from here, from my summary, I can now combine and I make the way we are doing this. I get 5 times X you get what? 5x. You add 6 plus 6 times y, which is 6y. Someone is asking. Yes, please. I explain where.
Yes, Abby, how
On the
have you got it?
capacity. Okay. Capacity, I said, when you observe, the statement given from here up to here, they are telling us that the production takes place in 2 different departments for each type of crop. The daily departmental capacity for regular is 80 and for deluxe is 60. They have specified capacity for each, the capacity you will need for each regular and for each deluxe. But they have not shown you, or they have not indicated the overall capacity of the company. Are we together? They have not indicated the overall capacity of the company. Like here, they indicated, they told us the overall man days. Here they told us the overall components. Here we don't have the overall departmental capacity. What we have is corresponding to each produce. So in a situation where you have such kind of statement, you look at each separately. You formulate inequality for each separately, like the way I was doing here. To do this, I am trying to create inequality for only regular crop. Because if I say 1 times x, it will be x, then plus 0, it should be less or equal to 80. In short, the departmental capacity I'm showing here, it's to help me to formulate inequality corresponding to regular crop separately. I cannot mix because I don't have the overall. Here I'm showing this to create inequality for only regular crop. But it can come also clearly on this step, the step we are doing. First, observe very well. So here we are saying the inequality is this. Then here 1 times x is x. Then plus 2 times y, what do you get? 2y. Then it should be less or equal to 160. Then here, we are here now. We are here now, it is 1 times x, which is x. In short, actually, I said if you get used, you will find that actually you are not doing this step. You will only be doing this immediately, not to waste time. And you realize that once you reach on this step, you just need to say x. The capacity for x. The capacity for x should be, the capacity for x should be less or equal to, or the capacity for x, the one that is available is this one, 80. Then for this one for y, it is limited to 60. It is limited to 60. You see that you have only X here, you have only Y here. You must be having Y and X in a situation where you are given the overall value. But if you're not given the overall value, you look at each separately. I don't know whether I have answered you. Are we all fine? Have you all understood this? Please confirm whether there is any, if you have the question, ask. Okay, okay. So as you interpret your case studies, you need to know that kind of situation, that if I'm only having one variable, or if I'm not having the overall total, then I have to look at each variable separately. I have to create inequality for each variable separately. But if I have the overall total, then I can sum up. I can sum up together. In my inequality, I must be having X and Y. You must be having X and Y in a situation where you have the total. Okay, okay, perfect. So we are done with constraint. The last one.
Recording in progress.
The last one should be your non-negativity. Colleagues, once you understand how to formulate linear programming model, other things are actually easy. So here, what do you do? Someone suggest? Someone suggest what should be our non-negativity?
X greater or equal to 0 and Y greater or equal to 0.
This is always free mark. This is always free mark. Never forget. So that is your linear programming model for question 2. Are you learning something?
Yes.
So finally, we can look at question 3. And we also form linear programming model. Once you formulate linear programming model, other things are very easy. That's why I'm labeling myself to actually formulate a linear programming model. You need to understand how to formulate linear programming model. So here they are telling us, of course, the steps remain the same. Identify and define decision variables. Hey, wait. For as if we didn't do objective function. For question 2. What is our objective function? Do we have the statement to give us objective function? A profit of shillings 5,000 is possible for regular and shillings 8,000 for deluxe. So we can just say here, this is 5,000. Is it 5,000 or 8,000? The first one is what? 5,000. This is 5,000. 5,000 related to X. Then we add 8,000. And your amount are in what? Are in shillings.
Shillings.
Or if you want, you reduce and say this is 5X plus
8y.
8Y, and you keep 1,000 in bracket. Perfect. That is question 2. Then we handle question 3 and we see what next. Okay, question 3. Question 3, they are telling us that Mr. and Mrs. Will marry a retired couple. Do we have retired couple here? Who have up to shillings 30 million to invest in securities. They have up to. Okay. We have up to shillings 30 million to invest in securities. Carissa, their broker, recommends investing in two bond securities. One of them is an AA bond. You have one bond, one security. The first bond is AA, and this first bond is yielding 12%. And the other bond is BB, yielding 15%. Something should come into your mind. After some consultation, the couple have decided to invest at most shillings. You are seeing the word at most now. Shillings 12 million in BB related bond, and at least shillings 6 million in AA related bond. Colleagues, every time you see the word at least, at most, up to, you must, it's a must that on that step indicate the inequality. Otherwise, if you don't indicate the inequality, you are going to mess up. The question can be very easy, but let me tell you, if you fail to formulate inequalities, if you fail to formulate linear programming model, you cannot pass. You cannot get all marks on this number. But if you formulate your linear programming model, you can easily score all marks. Very easy. So something should come into your mind here. Here they are investing at most 12 million, and here they are investing at least 6 million in AA. They also want the amount invested in AA bond to exceed or equal the amount invested in BB bond. Full stop. Simple as that. But this question was taking actually around 12 marks. That's why I don't normally indicate marks here. But this question was taking 12 marks. The question is, can you formulate linear programming model? Once you formulate linear programming model, then you can proceed to do what? To use this graphical method or simplex method, depending on the question you're handling. So we start. In this question, who can tell me the decision variables? What are the decision variables in this question? Yes, please.
I think AA and BB.
AA and BB.
BB.
Because those are the only two bond securities that we have. So we come back here. Our decision variables. Are AA bond and the BB bond. But we cannot keep on using AA bond and BB bond. So we can define let X. Sometimes on Roman 2, it can help you. Roman 2. They are telling you what? Determine the broker's recommendation if the couple want to maximize their return on investment. So let X represent a bond. Then Y represent the bond. Okay, that is step number 1. Now, number 2, objective function. Is it to minimize cost or to maximize? Who can formulate? This is where the challenge was. Who can formulate? The information, there is no error. Who can try? Happy? Kindly mute. Members, when you realize that objective function is giving you hard time, you first skip and handle constraints. But already you know that the couple wants to maximize what? The return on investment. So ideally, you want to maximize. You want to maximize, but at this point, you are still confused. If you're confused, first leave a space. Then you go to constraint. Constraints, every time you see those words that I told you, at most, at least, available, up to, limited to, more than, less than, the inequality is calling you a constraint. And we said each constraint formulates an inequality. So come back to your scenario. We start from here. Mr. and Mrs. Wumari are a retired couple who have up to shillings 30 million. What comes into your mind here? To invest in securities. To invest in securities. This is like the overall amount of money. And you have this word, you have up to. So which inequality can you put there? Which inequality can you put there?
Less or equals to.
Less than or equal.
I can skip some. I put less or equal to. Less or equal to how much? 30 million. Remember here you'll be having your X and Y. But at this point, you don't know. At this point, you don't know what you should put here. You don't know what you should put here. But you know the amount of money, the total amount of money available to invest in securities. They have not said security, they have said securities. So you have to combine. Next. Here you are just trying to interpret the question. Carissa, their broker recommends investing into bond securities. One of them is an AA bond yielding at 12%. And the other one is BB bond yielding 15%. Colleagues, if you analyze this, do you see any inequality here in this statement? Just be open, be free. This is a revision. If you suggest something wrong, you will be corrected. But what is your view?
My view, I think it is giving us.
Yes, increase on your volume. Continue.
I'm saying, I think it is giving us a profit function.
It's what?
Giving us the profit function.
The profit function, okay. Another person is saying there is inequality. Which inequality here? One of them is a bond yielding this. Then another is a bond yielding this. Now, which inequality can you put there? Remember, if this statement gives you hard time, at this point, if this statement gives you hard time, if you have confusion, first leave this statement and continue. Okay? Then you put a star. Let's first continue. Remember, in this question, you will need also objective function. Okay? Let's continue. After some consultation, the couple have decided to invest at most 12 million in a BB-rated bond. At most. And I said every time you see the word at most, immediately place inequality there. That is a separate equation. That is a separate inequality. You cannot mix. So it means that this 12 million is related to only BB related bond. This is like the way you was talking about departmental capacity. The way only capacity was related to a specific variable. Also here it is related to one specific security, which is BB. So we come back here. We come back here and put this is BB, the one available, the man available, the investment. You can use the word investment. Which inequality at most? Which inequality?
Less than or equal to.
Less than or equal to. And the figure is what? The amount is what? 12 million? Specifically to BB, related to BB bond.
It is true.
Colleagues, what are Wanji? Is the figure correct? Okay. Colleagues, what I'm doing is just trying to interpret. In an exam, these things, what I'm trying to do here, you can skip this step. For you, you immediately come up with a summary, like the way we are doing here. This is the summary the examiner is interested in, this one. Just what we are trying to do is to see how best can we interpret the question. So here, BB bond is what? Is it X or Y? BB bond is Y. So I can put here just 1 to recall that I'm dealing with BB bond. Then another one, here I can put 1 to indicate that here they use the word at least for AA. They want to be, they are saying they decided to invest at least this in AA related bond. So you come here and use the inequality. At least which inequality? At least should be that figure or above. And the amount is how much? 6 million? This is related to AA bond. This is both securities. Now, until we go back. The last statement, they are telling us that they also want the amount invested in AA bond to exceed or equal the amount invested in BB bond. Are you saying where you have exceed or equal? Press there immediately inequality. Exceed or equal. Which inequality can you press here? Exceed or equal. Which inequality can you press there?
Greater or equal to.
Your voice is very, very, very down. Pardon?
Greater
It's
or
greater
equal.
or equal to.
Now, once you press that inequality, you ask yourself, what are you going to put after that greater or equal? what are we going to put? What you are going to put is this statement. The amount invested in a BB bond. But you don't actually know the real amount of money invested in a BB bond. You don't know. What you have is actually the one that is available. The couple have decided to invest at most shilling this in the. So what you're going to do, this thing is where problem comes in. Just interpreting those statements. So once you put this inequality, we expect you to put BB is Y, and this one will be X. Do you agree with this statement? Because if we come back here, they want the amount invested in A. They want the amount invested in a bond. Do you know the real amount invested in a bond? Do you know it? Hmm? What is some minute I first pick this one? Okay, we are here. They also want, are you seeing my screen? What is which screen are you seeing?
You're seeing your screen, the very one we're on.
They are saying they also want the amount invested in AA bond to exceed or equal the amount invested in BB bond. And I said that the fact is, you really don't know the real amount of money invested in what? In AA bond. Just what you have is the limitation. You have the limitation here that these guys, this couple, decided to invest at most. This is not the exact amount of money. At most means you can actually invest that money or below, but that is real. That is not the exact amount of money invested. If they say this couple have decided to invest at least 6 million, it doesn't mean that they have actually invested 6 million. It means that they have decided to invest at least, it can either be that figure 6 million or above. But we don't know the real exact amount of money invested. Have you understood my interpretation for this statement, for this inequality? I assume that actually when you're defining X and Y now, it can give you the picture X and Y. X can represent the real amount of money invested in AA bond. Then Y represent the real amount of money or the exact amount of money invested in the BB bond. But at the end of it all, it's you, the person interpreting this question, to analyze critically and come up with the best inequality. Otherwise, if you say it should be 60, what was for A? For X, it should be 60, let's say 6 million X should be greater or equal to Y or to 12 million, like some of you, and I gave assignment, some of you did this, like this. This can be wrong. You are trying to actually say that the real amount of money is invested was 12 million and the real amount of money invested was 6, which is not true. At this point, because you have inequality, that cannot be the exact amount of money. You can know exact amount of money when they have used the word equal to. If it is equal to, now we'll be knowing the real ground. But if it is at most or at least, there is no ground there. So from our, and also you see another mistake that people did is, you see you have up to 30 million be invested. So people were combining 12 million, they said this is 6 million X plus 12 million Y is less or equal to 30 million, which is wrong. You cannot combine inequalities. Here you have a separate inequality, and here you have a separate inequality. Here you have a separate inequality. You cannot combine. So it's my humble request, colleagues, pay attention to the language of the examiner and try to understand what is the required. Okay? So it means that we are done. What is left is this statement. One of them is this. So this is going actually to help us to come up with objective function. 12% is on A, then 15% is on B. That's what you expect. So when you're coming up with the objective function, this can be like 12%. What was the first percentage? One of them is an AA bond yielding 12%. So I don't know the exact investment, the amount of investment, but I assume that I'm going to earn 12% on my investment. So it is 12%, and we define A represent X. Then I add 15% on Y, which is approximately 0.12x plus 0.15 Y. The fact that you don't know the amount you invested in X, this is like 12% on your investment in X. You expect 12% on your investment X, but do you know what the amount of money you invested? No, it is represented by X. Here you expect 15% on your investment Y. Okay. So in a summary here, if we summarize here, we have 1. If you find that you are in this situation, like here, you don't have something here, you don't have something here, but you have something here. You have this limitation. It means that you are just going to get x, you add y, and now bring this x plus y, then should be less or equal to 30 million. Then also here, now here it is 0. The fact that it is only, this one is for only one item or one variable, you cannot combine. You cannot combine. We expect you to only have a variable corresponding to this inequality, which is y. So I say y is less or equal to 12 million. Then here it is only, this inequality is only corresponding to a bond, so you cannot combine with y. I will just say x is, or here it is greater, so I use greater or equal to 6 million. Then I also have the last inequality, which is x is greater or equal to y. Full stop. Now I have my constraints, or I have my information here. Then I put non-negativity. And non-negativity should be x is greater or equal to 0. Then y should be greater or equal to 0. So that's all with question 3. And that's how, guys, we are supposed to come up with linear programming model. I think those illustrations are enough about to, but you will also do for question 4. Question 5, you have linear programming model, it is given. So no need of hassling here, it is given. But here they said you use simplex method, not graphical. Okay. So now the fact that we have tried to analyze how we can formulate linear programming model, we can now use graphical method. In other session, we will see how to use simplex method. Graphical method, using a graphical method. After formulating your linear inequalities or linear programming model, the next step is to convert. You convert inequalities. You convert inequalities into equations. That should be your first step. Convert your inequalities into equations. These are our inequalities. We are going to convert them into equations. Where there is inequality, you remove it and put equal sign. And this is your equation 1. This is your equation 1. Now, this is no longer inequality, but it is an equation. This is equation 2. Then this is equation 3. We have another one. M is equal to 0. But even if you don't put, this is just a line. cannot be an equation, but you just put in case. Then this is 0. That is the first step. Then once you do that, solve each equation separately. As you solve, what are you interested in? You're trying to get points to plot. On each equation. What are the points you should plot on each equation? What are the points you should plot on each equation? Remember, we are interested in a line. So you must be having 2 points so that you join. First point to the last point, you must have 2 points. Keep that one in your mind. That if the equation is not a line, this is just a line where you have only one variable, that is a line. That is not an equation. It is just simply, it will be a line. But where you have 2 variables, we expect you to be having points joining from the first point to the last point. So we start from equation 1. Is equation 1. Equation 1, this is what we have. Now we need the points to plot. When you just start and say when to ease your life, don't get a point that is going to give you hard time. When m is equal to 0, what can be your n? Substitute. Where there is m, put 0. So it will be 0 plus 2n, which is equal to 12. So this is 2n. 2n is equal to 12, and n is equal to what? N is equal to what? We divide by 2, n is equal to 6. So based on this point, you can plot, point to plot. Here, the points you have. M can be your, and here it doesn't matter that one student can decide to put M on vertical axis, another student can decide to put M on horizontal axis. But maintain what you have done. You maintain. You maintain. But always follow the way the question is phrased. The first variable, always make it your x. Then the next variable, make it y, or put it on vertical axis. The first variable on horizontal, the next variable on vertical axis. Maintain that procedure. But you cannot be penalized. But not to be confused, just maintain your things. So points to plot. Remember, the first point you put should be on horizontal axis. So we are saying it is 0, 0 is what? 6. So on horizontal axis, we will stand where we have 0. Then on vertical axis, we look for where we have 6. Then we also say when mn is equal to 0. This is just your assumption. You are just trying to get points to plot. You can decide to use when m is equal to 20, but don't get a point that is going to give you hard time to plot. Are we together, colleagues? Just use easy figures, 0, 1, or 2, or 4. Don't use those big figures. So when n is equal to 0, substitute in your equation. This is our equation. So where we have m, where we have n, we put 0. It will be m plus 2 times 0, which is equal to 12. Then m plus 0 is equal to 12, implying that your m is equal to 12. So here are the points you have. Remember, we start with x, or we start with the variable we want to put on horizontal. And based on my variables, the first variable is m. So I can decide, I have to decide to put it on horizontal. So if m is on horizontal, that is like your x-axis. So tell me, which figure should I start with here? Remember, we start with the value that you want to get on your horizontal axis. Which value? Should I put here 0 or I put 12?
So
12, then here 0. You maintain, if you have decided, say that this is my horizontal axis and I'm going to put m, make sure that you maintain that route. Don't change. So now we have this point and this point, and you are done with the fact that they are different, the figures are different. You can just decide to go to the next equation. Or some people, for accuracy, they get another point, but that is wasting a lot of time. That is wasting a lot of time. But if you
Recording in progress.
If you have time, maybe if you are seeing people are writing and for you, your content is done, you can decide to say, okay, let me add another point. When I decide to say when m is equal to 2, what can be my n? I substitute. I say m, no, I say it will be 2 plus what? 2n is equal to 12. Then this is 2n is equal to 12 minus 2. Then this is 2n is equal to 10. And finally here your n is equal to 5. So at this point, the points you have here are 2 and 5. That's if you decided to add the third one. Remember, in an exam, we find that sometimes you don't have a lot of time to do all of this. But if you have time, you can actually do that. So if you're plotting, you will be looking for these points. Go to the next equation. Next equation, you first get points to plot. Equation 2. What is our equation 2? It's here. That is my equation 2. I say when m is equal to 0, what will be n? What will be my n? It will be 2 times 0 plus n is equal to 12. 12 plus n equal to 12. Then here my n is equal to 12. Then this side, when I say when n is equal to 0, I substitute in my equation. Where there is n here, where there is n, I put 0. This is 2m plus 0 is equal to 12. If I'm following my equation, this one. So this is 2m is equal to 12, and my m is equal to 6. If you have time, you can add another point. You can also say when m is equal to 2, you can use any value. Substitute where you have m, look here, put 2. It will be 2 times 2 plus n is equal to 12. This is 4 plus n is equal to 12. So your n is equal to 12 minus 4. And finally, n is equal to what? 8. So points, here points. One person suggests we are starting with value on horizontal axis followed by value on the vertical axis. So here we put what? Hey, colleagues, where are you? Here we put what?
2 and 8.
2 followed by 8. Then here?
We put 6 and 0.
Here it is 6 followed by 0, or 6 against 0. No. Then here, our points.
It's 0 and 12.
And 12. You are done with equation 2. We go to equation. I thought we using 0 throughout. No, don't cram. Don't cram. We don't use 0 throughout. The reason why you see people using 0 is right. But you can use any value. What you're interested in is just to get points plot. And I'm adding another thing here. Just that is if you have time. If you have time. But if you have this and this, that is enough. If you have this and this, that is enough. Some people use this, the third one, to be accurate when they are making their line. You are going to see to be accurate. But you cannot be, they will give you all your marks if you have this one and this one, this one and this one. Here it is, don't cram that I have to use 2, I have to use 0, I have to use, you can use any value, but don't use the value that is going to give you hard time to plot. Okay, do we have the next equation or we are done? We have equation 3. Equation 3. Equation 3, this is my equation. This is my equation. And I can say when m is equal to 0, am I too fast or too slow? When m is equal to 0, I substitute 0 plus 1.2n is equal to 5. 1.2 2n is equal to 5. I have those with calculator. What is n? If you get 5 divided by 1.2,
4. 4.
so this is 4. Points plot. It is 0 and
Abel,
yes, please.
that the value of n is, I think it's 1.25 n.
Oh, sorry about that. Thank you. So if you get 5 divided by 1.25, you get 4.
0.25.
Get 5 divided by 1.25. Do you get 4?
It's 4.
Okay. Then next we say when n is equal to 0, I substitute. Where I have n, I put 0. So this is m plus 1.25 times 0 is equal to 5. So this is m plus 0 is equal to 5. My m is equal to 5. Points. These points must be different. If you realize that you're getting the same values, the points you have here must be different from the points you have here. If all figures are the same, you need to choose another value here. So the points to plot, it is 5, then 0. And then we can add another one when, say, m is equal to 2. Where there is m here, I put 2. This is 2 plus 1.2. N is equal to 5. This is sorry. This is 1.25. This is 2. This is 1.25 n is equal to 5 minus 2. Okay. So 1 is equal to 3. Then my n is equal to 3 divided by 1.25. What do you get? I'm waiting.
2.4.
Then here points to plot. It's 2 is 2.4. You're done. This one, you don't need to say when already. This is just, you don't need you don't need anything. This is enough. This is just a line. Where you are not having two variables in an equation, that is just a line. Okay. So once you have this, get your graph paper. Get your graph paper and put a vertical axis, put a horizontal axis, look for the scale. Now, when you're getting the scale, of course, you know that the first figure you have, this one, 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 this one. All those figures, you must be getting them on horizontal axis. So as you get the scale, you analyze your figures. Which scale can I use to make sure that all points fit on my graph paper. So for this, you can just use the scale of, if we use a scale of 2, can our values, will they fit? Okay, I'm expecting you to plot these things. Me, I'm just explaining. Yeah? On vertical axis also, you have this. The highest figure I think is 12. So also a scale of 2 can work, or even 1. You don't have negative values. So on your left of your graph book, suppose this is my, let me check whether I have some things here. Check. You're having your, which screen are you seeing? Colleagues, which screen are you seeing?
Plan of workings with
Excel.
equations.
What about now?
You seeing the
The graph.
Now I want you just put a vertical axis like this. And then you will put, my space is done. You will just put also horizontal axis down and plot. Like now here, this is my starting point. What are you follow your points? This is your point from your first equation. You need 0 on horizontal axis and 6 on vertical axis. You come here. This is where you find 0 on this starting point, then move upwards and look for where 6 is. 6 is here. So put a plus. Next. Next point is what? You can tell me. Next is 12 and what? 0. So 12 is on x-axis. So 12 must be somewhere down here. Here. So 12 is here, 0 is here. Because where you find y is equal to 0 is on this horizontal axis, this one. So I put a plus here. Then you get your ruler. If you have used only 2 points, you get your ruler, connect. From this point, put a ruler and join your point up to here. If you want also to indicate this, before you join, you have to also look for where 2 is, then 5 on vertical axis. 2 can be somewhere around, then 5 can be around here. So that when you're joining, all your points will be on the same line. You just put a ruler and you see that it should not be a curve, it should be a line. You use the ruler, join all your points, and name the equation. You see here I have tried, this is n, 2n plus m is equal to 12. That was our equation. For the other side, I started with 2n. but or you get the same. Or you get the same. This is your line. M plus 2n is equal to 12. Colleagues, do you have really the graph paper with you? Do you have a graph book, or you are just still saving the command?
We have.
So are you done with this line?
Yes.
We go to the next one.
Yeah.
We go. Did you approach all of this, or this one, and this one, or you just focused on only two?
Only
I
two.
beg your pardon on the third one.
The third one is just stand where on horizontal axis it is 2. Then vertical axis you look for 5. Like here, you'll find that 2 is somewhere here. Then 5 is here. Let me see. 5 will be somewhere like here. Then once you're done, put a ruler, wrong ruler, and join your points from the starting point to the last point. Is that line straight? Those who have used the three points.
Mine is straight.
You have used the 3 points or 2 points?
Me, I'm not.
3.
Please, if you are not getting, try to ask.
I am lost.
Where exactly?
I used.
Wanji, pardon?
I assumed my N and M was 0, and all my points out.
So for you, you have these points.
Yes.
That's what you have. Kindly confirm whether you have these points. Agnes, are you on? Now, if you have those points, the first one is 0 and 6. So 0 is on horizontal axis. This is where 0 is. This is where 0 is. Then look for where 6 is on vertical axis. 6 is here. You put a plus or a dot. Then go to the next point. The next point is 12 and what? 0. 12 is on horizontal axis, 0 is on vertical axis. So my 12 is around here, and I know that my y is equal to 0 is also on this point. So I put here a plus also a dot. Then if you have used only 2 points, get a ruler, start from here. Start from here. Join this point, this one with this one. It must be a straight line. You do the same for other points. Agnes, is it now okay?
Yes.
You do the same for other.
Thank you.
Do the same for equation 2. Once you join your line, colleagues, let me explain this. Once you join your line, before you go to the next equation, we need to know which side can we shade. Which side can we shade? What is the unwanted region? What is unwanted region? So, this is my equation. How do you know the unwanted region? This is my plus 2m is less or equal to 0. Okay? You guys, you are quiet. This should be 0. So what I'm
Abel,
doing. Yes?
we are equating that equation to 12, not 0.
Yes, this is 12. So if I choose 2 points that are below line, I choose, let's say 0 and 0. It means where I have n, I put 0, where I have m, I put 0. So it will be 0 is less or equal to 12. Is it true? You'll be asking yourself, is it true? Is it true that 0 is less than 12? 0 is less than 12. It is true. Yes. So it means that where you have yes, that is wanted region. That is the region you are interested in. Shade where you have no. Shade the other side. So that's why you see here the shading is this. And don't put a lot of art. Just put a few lines and move on. Have you known the reason why we are shading this side? The upper side?
No.
That is the logic you should apply. Let's go to the next line. You plot for me these points. I will also explain. First, plot this on your graph. This is 0. Then on vertical axis, look for where 12 is. It's somewhere here. Then the next point is 6 with 0 on the horizontal axis. You look for where 6 is. 6 is somewhere here. Then it is 6 with 0, and 0 is on this horizontal axis. If you are using only 2 points, just join. But if you are using 3 points, also come here and say 2 and 8. 2 on the horizontal axis, check where 2 is on the horizontal axis, then move upwards, check where 8 is. 8 can be around. 8 can be around here. 8 can be around here with 2 here. Eh? So you will find that you put, are your line straight? Those who have used the 3 points, is your line straight? Is it straight?
Yes, it is straight. Yeah, it is a straight line.
It is a straight line, eh?
Yes.
Have you used the 3 points?
Yeah, I've used 3 points.
Perfect. Now we need where can we need to know where can we shade. We apply our same knowledge. This is 2m plus n. The sign was what? Less or equal to 12. I get my points, my 2 points below the line. I always choose 0 and 0. Then I substitute. This is 0 is less or equal to 12. Is it true? Is it true that 0 is less than 12?
Yes.
Yes. So it means that you are going to shade where? You are going to shade this below the line. This is our line, and we picked our points that are below the line here, 0, 0. So if the answer is yes, it means that the side you picked those points is wanted region. You should shade the other side, and that's why you see the shading is also here up. We go to the next. The next one, you do this, plot this, this and this. And you tell me whether your line is straight.
Mine is straight.
Okay, so have you known where to shade? The inequality was what? M plus 1.25 N. The inequality was greater or it was less?
It was better.
Greater than what? 5. So we pick points below the line. Always just pick. Don't waste time picking the hard point. Pick 0 and 0. Then substitute. It will be 0 is greater or equal to 5. Is it true? Is it true that 0 is greater than 5?
No.
It's
So here you have no. Remember, we shade where we have no. So which side are you going to shade?
yeah.
Pardon?
The downer side.
Yes, the downer side.
The downer.
Yes, you do that. That's why you see I am shading down. Are we together, colleagues? Are you seeing the logic? Then the next one we are left with, the next one is to actually also do this, where M is equal to 0, N is equal to 0.
Yes.
Always make sure that you don't forget that. This I want to ask you, where do you find M is equal to 0? Where are you going to put that line? Where do you find M is equal to 0? Remember your M is this side, N is this side. But we want to find out where are you going to put the line to indicate that M is equal to 0? Is it this line or this vertical line or this one?
Horizontal.
Are you sure? If you put a horizontal, if you say that M is equal to 0 is here on horizontal, okay, let me not use 0. Assume you want to plot M is equal to 5. Where do you put the line? M is equal to 5. You put a horizontal line or a vertical line to show that M is equal to 5.
A vertical.
You have to put a vertical line, isn't it?
Vertical line.
So it means that for you to indicate M is equal to 0, for you to indicate that M is equal to 0, you have to put a vertical line. And this is your vertical line already. Just that you will name your line this one somewhere and say M is equal to 0. Then you also name your line here and say that N is equal to 0. However much this side you have M, but this line, this one, is the same as N is equal to 0. Then you shade down you shade down, then this side you shade moving this side on the left. You have to shade this side down. You have also to shade this side. And I believe after shading, do you have the side that is left unshaded? Do you have unshaded region?
Yes,
Yes,
Yes.
it's there.
I have.
Okay. Now, that is the one that is going to help us to make conclusion. We'll proceed now. So I want you to name where you have corners on that unshaded region. The first corner, I think it is here, then somewhere down. How many corners do you have? How many corners? You can indicate A. You show that this is your A. Put here A. This is B, point B. This is C. Everywhere where you have the meeting point. Then this is D. Do you have E?
Yes.
I have
The
E
first corner
also.
is here.
I have E.
Okay, so this is A, B, C, D, E.
And E.
Or you have another point.
No.
Okay, perfect. Now, the next burden you have is to know at point A, what are the points that gave you that meeting point? Read X alongside Y. You start with X, then followed by Y. So this is 0, 5, isn't it? Then for B, the points that gave you point B is what? It is 0 and then the point that is giving you C, you put a right. You put on your graph. You put a ruler, move down, read the value of X. Is it 4?
It is 4 and 4.
4 and 4. I don't know others whether they
Yeah, I have
have
4 and 4.
But this meeting, we don't have any gentleman. Okay.
They are there. But
They are in Kamodi. So what about D? Is it 6 and 0?
Yeah.
What about E? What about E? It is what? You are now quiet. It is what and what?
It's 0 and 4.
Are you sure you cannot say 0 and 4? You cannot
I
start
have
with
0 and 4 for E.
I don't accept that. 0, it is either you start with point here is not 0. X, when you are reading the value of M, is this 0 really? This is not 0. It is 4 and 0. We start with the value on horizontal axis, followed by the value on vertical axis. So the value on horizontal axis is it 4? It is 4. Then the value on vertical axis is 0. The same way we read this. The value here is 6. Then the vertical axis, the value is 0. So once you have those points, once you have those points, you come and do this. Put here vertices, create a column called vertices, then put here your objective function. Objective function. What was our objective function? Which is equal to? What was our objective function?
It was Z max.
Yes.
Z max is equal to 600 M plus
600 M
That's 400.
plus 400 N. And our values are in what? Our values are in 1,000. Is my network clear?
not very.
Okay. So what you are going to do is to indicate we have point A. Our point A, the points were what? You tell me the points on A, those values. Tell me. Start.
5
5 and what?
5 and 0. And 0.
Then B. Put some speed. Colleagues, put some speed. Pardon? 4. Then C.
It is C that is 4, 4.
It is C that is 4. What about B?
6, 0.
6 is 0. This is 4. Then D.
0, 6.
No. You are reading wrongly. You start with the value on horizontal axis, followed by the value on vertical axis. So it is what and what? 6 and 0. Then E, it is what and what? It was 4
E
and
is
0.
4 and 0.
Perfect.
It is 4 and 0.
All right. So we substitute where we have M,
Yes.
we put 5. Where we have N, we put. So let's substitute. This is on your calculator, I can start with my bracket to get 600, then multiply by 5, add 400, then times 0. What do you get? The first figure, what did you get?
It is
Is it my network or what? Someone is. It is what?
3,000.
It's 3,000.
What about the next one?
3,600.
3,600. Then you do the same for others. Plus 400 times 4. What do you get here?
It is 4,000.
Then you do the same for the next. Here the value of m is 6. So it is 600 times 6. Then add 400 times 0. What do you get?
3,600.
Then the last one is 600 times 4. Then plus 400 times 0.
It's to
What do you
400.
get? 400.
2,400.
2,400.
2,400. So once you have this, you are done. Just what you needed to do is to go to your question and see what was the question saying we maximize or what? The question was telling us to maximize.
Yes.
The question was
Yes,
saying
we will.
graphical method,
Maximizing.
determine how many items of each type that's to maximize profit. So we come here and ask ourselves, so colleagues, we come here and ask ourselves, this is like our profit. This is like our profit. What is the highest figure here?
4 million.
It is
Is 4,000.
So this is where we have the maximum. This is the maximum. Ask yourself, what are those points? Ask yourself, what are those points that helped you to get the maximum profit? The points that helped us to get the maximum points are what? M is equal to 4, and N is equal to what? N is equal to 4. So it means that the number of, therefore the number of regular clocks should be 4, and the number of X clocks should be also 4. And the last Roman 3, they say that what is the maximum profit? The maximum profit, the maximum profit, the maximum profit, how much? The maximum profit is this one. 4,000, but it is 4 million now. And that's how you can conclude. Is that hard? If I told the question was to minimize costs, you come here using graphical method. You come here and ask yourself, what is the lowest value? That is, if you want to minimize, you come here and ask yourself, what is the lowest value? That lowest value can help you to come up with this. But the fact that here we want to maximize, we pick the highest value. Then we ask ourselves, what are those points that helped us to get the highest value? And that will be your maximum profit, and this will be your output. And that's all. That is the knowledge you are going to use to do this, to do for question 2, to do for question 3. Just you have the model, get points to plot. Also for question 3, get points to plot, come up with a shaded region, get your shaded region. Once you have the shaded region, get these points and substitute in your objective function. Substitute in your objective function and get the value so that you can make the conclusion. Is it hard, colleagues? And that's how you are going to use graphical method. You use graph book or graph paper just to help you to get these points. Any question? Any question? Is everything clear? That's all with graphical method. Now it's your role to practice. It's your role to practice more numbers, and you will be good to go. You will be good to go. So next time we will handle a simplex method. That's enough for now, and stay blessed.